Welcome to qnawire.
Hi everyone, so what we have is a vertical piston that has a piston that is resting on a pair of stops. The air inside this piston, there is initially 1.2 kgs of air in there. The pressure is 700 kPa and the temperature is 200 degrees C. We know that 600 kPa is required to move the piston. There is a valve at the bottom of the cylinder such that the final volume is 0.8 or 80% of the initial volume. And we know that 40 kilojoules of heat is lost during this process. What we're asked to find is the final temperature, the mass of the air that escaped, and the total work that's done. So first what we're going to do is write down our assumptions. We know that this is not a steady state process because conditions within the piston cylinder are changing. Next, what we know is that any changes in kinetic energy and potential energy are assumed to be negligible and equal to zero. And we also are going to assume that air is an ideal gas that has specific heats that are constant at certain temperatures. So next, we're going to write down the properties of our air. So since we're dealing with air, we know the gas constant is 0.287 kilojoules per kilogram Kelvin. Next, we're also going to write down our CV value of air, which is equal to 0.733 kilojoules per kilogram Kelvin. Next, we're going to write down our CP value. Our CP is equal to 1.02 kilojoules per kilogram Kelvin. And these are all at a temperature of 450 Kelvin. So next what we're going to do is define our system. We're going to define the tank as our system, and when we do our mass balance, we know that the mass coming in minus the mass leaving is equal to the change in mass of the system. So we can go ahead and say that Mi minus M0 is equal to M2 minus M1. However, we know that there's no mass that's coming in, so Mi is 0, so all we have is Mo, which is the mass that's leaving. So we can say that Mo is going to be equal to M1 minus M2. Next, we can do our energy balance. So we can say that the energy coming in minus the energy leaving is equal to the change in energy of the entire system. So now what we can say is we can say that we have boundary work that's coming in minus heat that is lost minus the enthalpy that leaves is equal to the change in internal energy. So that's going to be M2U2 minus M1U1. We can use our definition of specific enthalpy and specific heat with our CP and CV values to say that this is also equivalent to writing the work minus the heat minus ME. CP TE is equal to M2 CV T2 minus M1 CV T1. Next, what we're going to assume is that the exiting temperature is the average of the initial and final temperatures. So what we're going to say is that TE, which is the temperature of the air leaving, is 1/2 T1 plus T2. And by plugging in for T1 and T2, we see that TE is equal to 1/2 times 473 plus T2. Next, we're going to use the ideal gas law to solve for our initial and final volumes. So we know our initial volume will be equal to M1 R T1 all over P1. And this gives us an initial volume equal to 0.2327 cubic meters. Now, given in the problem statement that the final volume is 80% the initial volume, we can say that V2 is equal to 0.8 V1, which gives us a final volume equal to 0.1862 cubic meters. Now again, by rearranging the ideal gas law, we can solve for the final mass and say that M2 is equal to P2 V2 all over R T2. And by plugging in for these terms, we see that we can get the final mass in terms of T2. And this is equal to 389.18 T2 kilograms. Therefore, we can say that the mass that leaves, Me, is equal to M1 minus M2, which is going to be equal to 1.2 minus 389.18 T2 kg. Now what we can do is next solve for the boundary work. We can say that WV is equal to P2 V1 minus V2, and this is equal to 27.9 kilojoules. This is actually one part of our answer. Next, what we can do is we can substitute all of these terms that we've put in terms of T2 or just their numerical value and plug those in to our energy balance equation. Recall our energy balance equation was W out minus Q minus ME CP TE is equal to M2 CV T2 minus M1 CV T1. Now, W out and Q we have numerical values for. We determine ME and TE in terms of T2 as well as M2 as well. So all we have left is everything to solve for in terms of T2. So we have one equation, one variable, and solving this equation gives us a final temperature equal to 415 Kelvin. So that is another part of our answer. Lastly, remember we're asked to solve for the mass that has escaped. So our mass that has escaped expression is ME is equal to 1.2 minus 389.18 all over T2. And this gives us a mass that escaped equal to 0.262 kilograms. And that's our final answer.